morning, dear students. Myself, Dr. Priya, working as Associate Professor in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In today's presentation, we are going to cover problems that were based on EDTA method. In the previous session, we got a clear idea about estimation of hardness of water sample by complexometric method using EDTA. So, basing on that one, today we are going to study about how to solve the problems. So, here the problem, it is given like 0.28 grams of calcium carbonate was dissolved in HCl, a very small amount of HCl, and the solution was made up to 1 liter with the help of distilled water. That means this is nothing but preparation of standard hard water solution, that is step 1 in EDTA method. That is, while estimating the hardness of given water sample, it is having 4 different steps when we go to experimental procedure. Step 1 is nothing but preparation of standard hard water solution. So, for that, in the problem, it is given like 0.28 grams of calcium carbonate was dissolved in this very trace amount of HCl, and the solution was made to 1 liter with the help of distilled water. So this solution, the standard water solution of 100 ml of this above solution consumed 28 ml of EDTA on titration. So, when this 100 ml of above was prepared solution, when subjected to titration using disodium salt of EDTA, it consumed 28 ml of EDTA for the same. So, and then this is nothing but step 2. From step 2, we are able to calculate molarity of disodium salt of EDTA using step 1 molarity, that is molarity of standard water solution. And coming to the next step 3, what data it is given in the problem is 100 ml of hard water sample. That means sample it is supplied to you. From that we have to transfer 100 ml and we have to follow it that one for titration using disodium salt of EDTA. How much it is consumed? 33 ml of same EDTA was consumed. So, in step 3, 100 ml of hard water sample required 33 ml of same EDTA solution for titration. So, this is step 3. From step 3, we are able to calculate total hardness of the supplied water sample. And we will go for step 4 data that is given in the problem. After boiling and then filtering, so that water sample that was supplied in step 3, so it is to be boiled and then followed by filtered. And then from that we are going to use 100 ml of boiled and filtered hard water sample. So, this is mentioned here, cooling and then filtering. And then titration required or consumed 10 ml of same EDTA solution. 10 ml of same EDTA solution. So, data for step 4 data it is also given. So, using all these data for step 1, 2, 3 and 4, we are going to calculate now temporary, permanent and total hardness of the supplied water sample. So, let us see the solution part. So, as I told you, step 1 it is meant for calculating molarity of standard water solution. Molarity of standard water solution. So, how it is calculated means, we have the formula M is equal to weight of what salt it is given in the problem? CaCO3. So, weight of calcium carbonate divided by gram molecular weight of CaCO3 into 1000 by V, it is taken in milliliters. So, using this formula, we know the weight of calcium carbonate, it is mentioned in the problem, it is given in the data. Weight of calcium carbonate, it is equal to 0.28 grams, and what is its gram molecular weight? It is equal to 100 grams. So, substituting in this formula, weight of calcium carbonate divided by gram molecular weight of calcium carbonate into 1000 by V in milliliters. So, V value it is given like 1000 because we prepared a standard water solution by using distilled water up to 1 liter. So, V value it is 100. By substituting all these things, we got the answer as 0.0028 m. Weight it is given like 0.28 divided by 100, that is gram molecular weight of CaCO3 into 1000 by 1000. These two things get cancelled and finally we will get 0.0028 m, that is molarity of standard water solution. From step 1, we calculated molarity of standard water solution. So let us go for step 2. Step 2 is nothing but determination of molarity of EDTA. Molarity of EDTA we are going to calculate in step 2. So for that we are going to use the formula, that is M1 V1 by N1 is equal to M2 V2 by N2. So in this we know that N1 is equal to N2 is equal to 1. N1 is equal to N2 is equal to 1. Number of moles it is equal to 1. So what is M1? 1. Always 1. Number 1 represents standard water. 1 it is meant for representing standard water. 2. 2 always represents EDTA in this experiment. So what will be M1? Molarity of standard water. So in step 1 we got its answer. In step 1 it is obtained as 0.0028. Okay. And then what is V1? Volume of hard water sample, that is 100. And then what is M2? M2 is a question mark, we have to find out, that is molarity of EDTA. What is V2? How much amount it is consuming? For 100 ml of standard water solution required 28 ml of EDTA, that is given in the problem. So V2 value it is equal to 28. So by substituting all these values, we got the molarity of EDTA as 0.01 m. So what I want is M2. So equation becomes equal to M2 is equal to M1 V1 by V2. So substituting all these things, 0.0028. This is molarity of standard water which we got in step 1 calculation into. So what is the volume of standard water we used? 100 ml divided by what is the volume of EDTA that is consumed for this titration? It is equal to 28. It is given in the problem. So by substituting all these things, we got the molarity of EDTA as 0.01. So from step 2, we got molarity of EDTA, that is 0.01 m. Step 3. Step 3 it is meant for calculation of total hardness. Calculation of total hardness. Total hardness it is calculated by finding out M3 value. What is M3 is? M3 is molarity of hard water sample. In step 3, hard water sample will be supplied and we are going to calculate its molarity using step 1 and step 2 data. So that after substituting this M3 value in total hardness formula, we are able to get the total hardness of the given sample. So let us see how it is. So formula it is, we know very well, M2 V2 by N2 is equal to M3 V3 by N3. So N2 is equal to N3 is equal to 1. Number of moles it is always equal to 1. So we can neglect these two values. So formula becomes equal to M2 V2 is equal to M3 V3. So M2 V2 is equal to M3 V3. So in this what I want to calculate is M3 value. So M3 is equal to M2 V2 by V3. So what is M2? Molarity of EDTA which we calculated in step 2. Okay. So its value it is equal to 0.01. And then what is V2? Volume of EDTA consumed for step 3. In the problem it is given like 33 divided by volume of what is M3? Molarity of hard water sample. It's a question mark, we have to find out. So this one we have to find out. And what is V3? Volume of hard water sample that is considered for titration. So it is equal to 100. So after substituting all these values, we will get a molarity of hard water sample. Here we got the result as 0.0033 molar. That is molarity of hard water sample. So now what we are going to do is, this M3 value we are going to substitute here. What is the formula for calculating total hardness? It is equal to M3 into 1000 into 100 ppm. So in this, if M3 value it is substituted, that is 0.0033. So we are getting total hardness as 330 ppm. So this is step 3 solution. And coming to the step 4. Step 4 it is nothing but calculation of permanent hardness. So for this what we have to do is, that water sample that is supplied to experiment is taken and then it is boiled and then followed by filtering and then cooling. So from that we are going to make use of 100 ml for this titration to take place. Okay, so in this case, how much amount of EDTA it is consumed by that boiled and filtered hot water? It is equal to 10. So using this data that is given in the problem, now we are going to calculate step 4, that is permanent hardness. So for this one, same, M2V2 by N2 is equal to M4, this is step 4, so M4V4 by N4 formula will be. And we know that number of moles, it is always equal to 1 for this reaction. So we can neglect N2 and N4 values. So what I need is M4. I just want to calculate M4. M4 it is equal to M2V2 by V4. So what is M2? It is molarity of EDTA that is obtained in step 2, like 0.01. It is obtained as 0.01 into what is V2? Volume of EDTA consumed for this step 4. How much it is given in the problem? It is given like 10. So whole thing divided by, I just want to calculate M4, that is molarity of boiled and filtered hot water sample. So in the denominator we will get V4 only. What is V4? Volume of boiled and filtered hot water sample. So everywhere we are taking it as 100 ml. So after doing this calculation and simplification, we got the molarity of boiled and filtered hot water sample as 0.001 molar. So this is the M4 value that we obtained from step 4. So after finding this M4 value, we have a formula that is permanent hardness, it is equal to M4 into 100 into 1000 ppm. By substituting this M4 value, that is 0.001 m, we will get this permanent hardness answer, that is 100 ppm. If we simplify this expression, we will get a result as 100 ppm. So in step 3 we calculated total hardness, and in step 4 we calculated permanent hardness. So according to the formula, we know that total hardness, it is equal to temporary hardness minus permanent hardness, right? So what I need is temporary hardness. It is equal to total hardness minus permanent hardness. So substituting that total hardness, it is equal to 330 minus permanent hardness, it is 100. So we got it as 230 ppm. So this is the formula that we use for calculating temporary hardness. That is, temporary hardness is equal to total hardness minus permanent hardness. So from step 3 we got total hardness as 330, permanent hardness in step 4 we got, it is 100 ppm. By substituting, we will get a temporary hardness that is equal to 230 ppm. So this is a solution for problems that were based on EDTA method. So just like in the experimental procedure, we have 4 steps. Same 4 steps we have to follow up for finding out the solution. So in today's class, so far what we have discussed is problems that were based on EDTA method. Using EDTA experimental method, if data it is given, the titer values and their volumes, if they were given, volumes of water samples and volumes of EDTA consumed for each step in EDTA method. So using that data, if data it is given in problematic form, the data we are going to calculate the amount of hardness that is present in the supplied water sample in terms of temporary, permanent and total hardness. In the next session, we are going to focus on what are the specifications of potable water, or we can call it as drinking water, and what are the methods that we use for disinfection treatment of potable water. So what kind of methods are there and what are preferable for doing disinfection treatment for potable water. So before going to this actual method, we should have an idea about specifications of potable water. So that's all for today's class. Thank you so much.